So now let's go ahead and multiply some complex numbers. Okay, so we're going to simplify. In order to simplify, I have to remove the parentheses by doing the indicated operation, which is multiplication. So I'm going to go ahead and distribute. So 3 times 5 is 15. 3 times negative 3i is 9i. Now remember that I squared equals negative 1. So then we're going to distribute the I. So 5 times I is 5i. And I times 3i is positive 3i squared, right? Because I'm multiplying I twice. Now we're going to combine the like terms. I see that I have negative 9i plus 5i. So that's 12i. Okay, now I see that I can still continue simplifying. I see that there's an I squared. I can continue simplifying that I squared. I know that I squared is negative 1, so I can place I squared with negative 1. So now this becomes negative 15, 4i. 3 times negative 1 is negative 3. 15 minus 3, that's 18 minus 4i. And it's an A plus BI form, so that's good. Alright. So these are complex numbers. I represents the imaginary number. We know that I squared equals negative 1. We also know that the square root of negative 1 equals I. Okay, let's move on. So we added complex numbers, we've multiplied complex numbers. Now let's go ahead and also continue performing operations with complex numbers. So we have 3b. Let's go ahead and distribute. 3i times 4, that's 12i. 3i times negative 6i, that's negative 18. I squared, right, because we have two i's we're multiplying. This is going to equal 12i minus 18. I squared is negative 1. So that's 12i plus 18, because negative 18 times negative 1 is positive 18. But I need it to be in a plus bi form, so I have to put the integer first, then the imaginary number. Let's do another one. Square root of negative 9 times the square root of negative 4. So here we're multiplying two negative radicands with an even index. So here I'm going to simplify this to square root of 9 times the square root of negative 1. And this one's going to be, and remember we're still multiplying. So now square root of 9 is 3, square root of negative 1 is I. So this becomes 3i times this becomes 4i. So 3i times 4i is 12i squared. 12i is I squared is 12 times negative 1. I'm sorry, I messed up over here. Oops. Okay, so this comes down to 3i. And this comes down to square root of 4 is 2. Square root of negative I is I. Square root of negative 1 is I. 3 times 2 is 6. I times I is I squared. I can keep simplifying because I know that I squared is negative 1. And 6 times negative 1 is negative 6. Okay. Okay, let's move on. Okay. Now let's go ahead and divide complex numbers. So remember the conjugate. Okay, you're going to need this here. Okay, so here we have 4 plus 3i over 2i. Now for something to be fully simplified, now we have to divide here. So for something to be fully simplified and divide, I gotta get rid of this I in the bottom. I cannot have an I in my denominator. So I have to get rid of it. I know if I multiply it by I can go ahead and get rid of it. One second. Okay, so we have, here we have 4 plus 3i over 2i. Now remember, I have to multiply. I cannot have I in my denominator, so I have to get rid of this I. I have to divide it out. So now I'm just dividing here, so I only have one term in the bottom, so I can go ahead and divide both top so 4 divided by 2, that's 2i. So here we have 4 plus 3i divided by 2i. So what I'm going to do is I gotta get rid of that I in my denominator. I can't have it in the denominator, so I'm gonna go ahead and multiply it top and bottom. Okay, because I know that I times I is going to give me I squared, which is negative 1, and that's gonna get rid of my I. Right? I'm multiplying it by my least common denominator. So now this becomes 4i plus 3i squared, right? Because this is like that, right? Divided by 2i times I, that's I squared. So now I can keep simplifying because I have 4i plus 3 times negative 1, because I squared is negative 1, and in the bottom I also have negative 1. So it's 4i minus 3 divided by negative 2. Now I can go ahead and simplify by splitting them up over my denominator, since it only has one term. 4i divided by negative 2 is negative 2i. Negative divided by negative is a positive, and then we can't simplify 3 2 over more. But I need to put it in a plus bi form, so I have to put 3 over 2 first. Remember, whenever you want to rearrange the order of any terms, you take the sign of the term. So that's positive 3 over 2, negative 2i, negative 2i. Okay, let's move on to our last question. We have 1 plus I over 5 minus 3i. Now remember we talked about our conjugate, a plus bi is a minus bi. Okay, so now in order for something to be fully simplified, remember I can't have I in the bottom. I can't have imaginary numbers in the bottom. So in order to get rid of this I know I have to multiply it by the conjugate. So the conjugate is basically the same thing. The only thing you're changing is the sign. So I'm keeping everything the same, just changing the sign. So now I'm going to distribute, right? I'm going to multiply it out. So that's I times 5, I times 3i, so that's 3i squared, over 5 times 5, 5 times 3i, negative 3i times 5, and negative 3i times 3i. Oh, look what happens here now. The 15i cancel out. So now I'm left with, I can simplify the top here. So that's 5 plus 8i plus 3i squared over 25 minus 9i squared. I can keep simplifying, right? This I squared equals negative 1. I can do that in the bottom too, right? 9 times negative 1. And I'm going to go ahead and continue this. So that's 5 plus 8i minus 3 over 25 plus 9. 5 minus 3, right? I can combine it like terms. That's 2 plus 8i over, we have 25 plus 9 in the bottom. That's 34. Just want to make sure that's not 81. That's an I. So I can keep simplifying. I can split this up. 2 over 34, that can be simplified to 1 over 17 plus 8, 4 goes into 8, 2 goes into 8 4 times, and so this, the answer is, I was going to write the answer right here, 1 over 17 plus 4 over 17i. Now you have to write it like this, separate it, because it has to be an a plus bi form. And that's it. If you have any questions, please email me.